Hello, hi everyone. This is Brijesh from Mechatronics in I'm studying Mechatronics in Swimming Kishore College of Engineering. Today's my topic is estimation of the estimation of the solar radiation by using the hybrid CNN catboost method. It is the topic. The abstract is that the conventional neural network and catboost algorithm for estimating solar radiation. The purpose of the method uses the CNN to extract the features from the input data, which are then fed into the catboost model to predict the solar radiation. The model was trained and tested on a large data sets of metallurgical variables, and the results were compared with others state-of-the-art methods. The experimental results show that the proposed method outperforms the other models in terms of accuracy and generalization capability. The proposed hybrid CNN catboost approach can be useful in various applications related to solar energy, such as solar power forecasting and energy yield estimation. These are my contents. Next, introduction. Solar radiation is an important parameter in solar energy system as it determines the amount of energy that can be generated from solar panels. Accurate estimation of solar radiation is essential for the optimizing the performance of solar energy systems and reducing the cost of energy production. The various methods have been proposed for the estimating solar radiation, including statistical, physical, and machine learning based methods. Machine learning based methods, practically deep learning techniques, have shown promising results in solar radiation estimation due to their ability to capture the complex pattern in the data. Convolutional neural network are a popular type of deep learning algorithm that have been used in the various image and signal processing applications. Catboost is a machine learning algorithm that is based on gradient boosting and has shown good performance in various regression and classification tasks. We propose a hybrid approach based on the CNN and catboost for estimating solar radiation. The proposed method uses the CNN to extract the relevant features from meteorological data, which are then fed into the catboost model for predicting the solar radiation. The performance of the proposed method is evaluated on a large dataset of meteorological variables, and the results are compared with other state-of-the-art methods. The experimental results demonstrated that a proposed hybrid CNN catboost approach outperforms the other methods in terms of accuracy and generalization capability, indicating its potential for practical applications in solar energy system. These are the literature survey. Susan Kimet Thong, Agwin, Ramin Professor Ravish C. Dio, David developed the hybrid convolutional neural network multi-layer acceptor model for solar radiation prediction. This is published in November 2022 in an article that have used the hybrid models for solar radiation prediction, including model combined machine learning algorithms, physical models, or statistical models. The challenges associated with it is using deep learning models for solar radiation prediction, such as the need for large amount of high-quality training data, the risk of overfitting, and the difficulty of interpreting the model's output. The potential benefit of using a hybrid approach that combines deep learning models with other techniques such as physical models or statistical models to improve the accuracy and interpretability of the model. The potential applications of the solar radiation predictions such as solar power forecasting, energy yield estimation, optimization of solar energy systems, and our discussion of a hybrid approach could be used to address these applications. This is the second paper, Omar Ali Karman Tuatayal. This is in Ajir Ismail said, I developed a solution of the solar radiation using modern methods. It is published in a journal paper that is Alexander Engineering in the year of 2021 April. Different methods to estimate solar radiation include empirical models, radiative transformer models, and machine learning models. The limitation of the existing solar radiation estimation is such as their reliance on specified or incomplete input data and their inability to capture the complex spatio-thermal relationship that affects solar radiation. The potential benefits of using machine learning models of solar radiation estimation, including their ability to have complex feature representations and their potential to generalize well to new data. And this is the third literature survey research paper. Mahol, Gurumai, Farid, Melgani, Qasim, Khaira, Muhammad, Amin, Mekhalif developed a comprehensive review of hybrid models for solar radiation forecasting. It's been published in the Journal of Clearance Production in the year of 2020, June 10. Use of the hybrid models for solar prediction forecasting, including the models to combine physical models with machine learning algorithms. Challenges associated with solar radiation forecasting, such as the complexity of the atmospheric process that affects solar radiation, the variety of the solar radiation across time and space, and the need of incorporate both meteorological and solar radiation data. Our decision of the potential benefits of using hybrid models for solar radiation forecasting, including their ability to leverage the strength of different models and data sources, and their potential to improve the accuracy and reliability of solar radiation forecast. What is convolutional network? It's a type of deep learning neural network that is commonly used in the image and video processing task. By using the convolutional neural network, we will We will estimate the solar radiation to extract the feature from the input image. In this layer applies a series of teachable filters to create a series of activation maps, which indicate the existence of particular characteristics in the image. Each filter convolves over the input image. The convolutional layers resulting activation maps are reduced in spatial size by the pooling layer. This helps to control the overfitting and reverse an amount of computation needed in subsequent layers. What are activation functions? To hand nonlinearity to the network, this layer arguments the output of convolution layer using a nonlinear activation function. The real sigmoid and tan H activation functions are frequently used. The output layer is connected to the previous layer of neurons through this layer, which is fully connected. It is used to categorize the input image using the attributes that have been learned. The output layer creates the network ultimate product, which is a probability distribution over the consumer classes. What is hybrid catboost method? Hybrid catboost method is a gradient boosting algorithm that is particularly effective at handling categorical features in data. Hybrid catboost combines the strength of catboost with other models or techniques to improve its performance in a specific task. Hybrid catboost models can leverage the strength of different models such as convolutional neural networks or physical models to extract a feature or incorporate additional data. By combining the different models or techniques, hybrid catboost models can improve the accuracy, robustness, and interpretability. Hybrid catboost models are often used in complex machine learning tasks where the data is high-dimensional, heterogeneous, or exhibits complex relationships that cannot be captured by a single model or technique. Estimation of solar radiation. With the input, they collect the weather conditions like temperature, relative humidity, cloud volume, exotmospheric solar radiations, and it will reshape and pass through the convolutional one-dimensional, then flatten and dense, then it will move to prediction. The convolutional neural network is a two type of layers. First is the future extraction and classification, where the future extractions are the like parameters. See the weather and temperature, relative humidity, cloud volume, atmospheric solar radiations are the parameters that that captures input, and then it will send to prediction. Then it will send to prediction. Here the catboost method is used to improve the robustness and it uses the high quality. It uses the high quality high quality data. It helps to improve the robustness and analyze the data. High quality data collection and repurposing. How we get data to estimate the total radiation. The data is used to like CNN catboost approach often consists of the weather factors that have been impacted solar radiation such as the hair molecules on temperature, solar radiation impacted by the temperature because it impacts how much energy a surface can absorb and reflect. By using the hair and temperature, we can also measure the solar radiation because if the temperature is high, then sunlight will be more and the air will be high, then it will be cool or not. If there is a cool, then it will be a little bit sun solar energy. The amount of water vapor in the air as compared to the maximum amount of that can be held at a particular temperature is known as relative humidity. Relative humidity affects the quantity of water in the wind, which may affect solar radiation. Cloudiness is a metric for how much of sky is covered in clouds. The amount of radiation from sun that reaches the Earth's surface is influenced by clouds' ability to reflect and observe it. Reprocessing was employed to rebuild the weather data. The analyzed what preferred at 18 sites as shown in the figure, and the location where the radiation of the sun value or cloud environment amount had been absent for a considerable amount of time were eliminated. Data collection centers are located at the points, areas, and sites are noted in the red dots. As shown in the figure, see these are the red dots where the data get from. Data collections. Data collects solar radiation. It will store the data and get the whole data to CNN model. If all these are positive, then it will give a positive. Then if some are negative, some are positive. If two are negative, if two are positive, then it will give a positive. That way of the working. Results on the parameter. Solar radiation estimates. The hybrid CNN types model is used to predict the solar radiation values at a specific location and time based on the input of data. The final result variable is estimated value of the solar radiation. The model performance matrix. The accuracy of the hybrid CNN catboost model can be evaluated using the various performance metrics such as the mean observed error, root mean square, or coefficient of determined R square. This matrix provided a quantitative assignment of the model's accuracy in estimating solar radiation. Feature important scores. The hybrid CNN catboost model can be used to determine the relative importance of different input features in predicting solar radiation. Feature importance scores indicate which input variables have the greatest influence on the model's prediction. Visualization. The hybrid CNN catboost model may produce visualization of the input data and model prediction. For example, the model may produce maps of solar radiation estimates or the and series plots of predicted values. This visualization can help to interact the model results and communicate them to stakeholders. Advantages and disadvantages. Coming to the advantages is input accuracy. The accuracy will be more depend on the input data. Reduced error. The error rate will be more compared to statistical models or physical models, and it will be faster training. Robustness and scalability. Coming to the disadvantages, complexity. It moves complex and interpretability. Data requirements. The collection of the data requirements is more complex. Overfitting the fitting. We need to study more areas to get the data. Generalizability. Application in solar power system. If we put a estimation of solar radiation, then we know the where the solar structure is more. And there we put solar panels to produce the solar power system and agriculture. If we know the solar radiation, then we will improve the agriculture and it will able to climate studies and weather forecasting and also able to environmental monitoring. After remote conclusion, the hybrid CNN catboost model is a promising approach for estimating solar radiation as it combines the strength of CNN and catboost to improve accuracy and reduce the error in the estimation process. While the model offers several advantages over other methods, there are also potential disadvantages to consider, such as the model complexity, interpretability, and data requirements. Ultimately, the suitability for the hybrid convolutional neural network catboost model for a specific application will depend on the ability of data, the complexity of the problem, and resource available for implementation and maintenance. These are my references. Thank you for listening.